68 miles every second. That's how fast the Andromeda Galaxy barrels toward us right now. The universe keeps expanding and galaxies usually run from each other. But Andromeda charges straight at the Milky Way like it picked a fight. That motion never made sense, until now. Most galaxies behave like dots painted on a balloon. Blow the balloon up and every dot moves away from the others. That's how cosmic expansion works. Space itself stretches, carrying galaxies with it. But Andromeda ignores that rule. It approaches us at roughly 150,000 miles per hour, and that puts it on a direct collision course with our galaxy. Scientists knew about the future crash for years, but they never fully understood why Andromeda overpowered the universe's expansion in the first place. Now, they figured out that both galaxies sit inside a massive, flat sheet of dark matter. You can't see it, but you can see what it pulls on as it has gravity. Instead of forming a neat ball around the galaxies, this dark matter spreads out more like a gigantic pancake, stretching across millions of light years. And that flat shape changes everything. Gravity works like tension in a stretched rubber band. Put a bowling ball on it and the fabric dips. Roll a marble nearby and it curves toward the heavy ball. The Milky Way and Andromeda sit on the same stretched sheet of dark matter. That sheet doesn't pull evenly from all directions like a sphere would. It pulls more strongly along its flat plane. That uneven tug slows the outward motion of nearby galaxies and pulls Andromeda inward. And space doesn't just contain galaxies, but also enormous empty regions called cosmic voids. These regions expand faster than average because they hold less matter. When they stretch outward, they push matter toward their edges and build dense walls of galaxies and dark matter around them. The Milky Way and Andromeda sit near one of these cosmic walls. The faster the void expands, the more it funnels matter into the surrounding structure, and that reshapes how gravity flows through our neighborhood. So instead of two lonely galaxies drifting toward each other by accident, it's a whole landscape that's shaping their motion. Dark matter forms the terrain. Voids carve out valleys and ridges. Gravity acts like water running downhill. Andromeda doesn't just decide to approach us. The entire structure of our local group, that's the small family of galaxies that includes us, guides its path. That local group stretches about 10 million light-years across. Each light-year equals nearly 6 trillion miles. Even at 68 miles per second, Andromeda still needs about 4.5 billion years to reach us. That sounds comfortably distant, but in cosmic terms, that's basically tomorrow. Earth formed about 4.5 billion years ago. The timeline of our planet and the countdown to this galactic collision almost match. When the two galaxies finally meet, they won't smash like solid objects. Galaxies mostly consist of empty space, and stars sit trillions of miles apart. During the merger, most stars will slip past each other without direct impact, but gravity will twist everything. Long tidal tails, huge streams of stars, will stretch out like glowing ribbons. Gas clouds will collide, spark furious waves of star formation, and light up the darkness. Over billions of years, the Milky Way and Andromeda will blend into one giant elliptical galaxy. A rounder, puffier system that astronomers sometimes nickname Milkomeda. Alright, but what about us? The solar system will likely survive the chaos, but it won't stay untouched. Our position inside the galaxy could shift dramatically. We might move farther from the galactic center or swing into a new orbit entirely. The night sky will transform. Andromeda already appears as a faint smudge about 2.5 million light-years away. Over the next few billion years, it will grow larger and brighter until it dominates half the sky. Stars will scatter into new patterns. Constellations will lose their shapes. The sky your descendants see won't resemble the one above you tonight. So, for decades, scientists assumed Andromeda approached us simply because gravity between the two galaxies overpowered expansion at short distances. That explanation worked, but it left gaps, such as why that exact speed and why that specific trajectory. The new research shows the motion doesn't come from just two galaxies tugging on each other. It comes from a whole invisible architecture. dark matter sheets and expanding voids, shaping space like scaffolding behind a building. Dark matter itself still remains one of the biggest mysteries in physics. It doesn't emit light, and telescopes can't photograph it directly. Scientists detect it by watching how galaxies rotate. Stars at the edges of galaxies move faster than visible matter alone could allow. Something unseen adds extra gravity. That something makes up about 85% of all matter in the universe. Regular matter, that's everything you can touch, makes up only about 15%. You live in the minority material. In fact, new research shows that even the supermassive black hole at the heart of our Milky Way is a supermassive but compact clump of dark matter. That dark matter might be made of super light particles called fermions that can clump together into an extremely dense core surrounded by a wider, fuzzy halo. This structure could reproduce everything we've observed around Sagittarius A star, the Milky Way's supermassive black hole. Everything from the crazy fast orbits of stars right near the center to the slower rotation of stars further out in the Milky Way. So, this massive dark matter clump would put out the same gravitational pull that we've been attributing to a black hole all this time. One of the most famous pieces of evidence for a black hole in our galaxy came in 2022, when the Event Horizon Telescope captured an image that looked like a shadow. A dark circle surrounded by glowing gas, right where Sagittarius A star should be. But new models suggest this dark matter core could cast a shadow that looks almost identical to the one we saw in that image. It means our best visual proof of a black hole might not be what we think it is after all. The study leans on data from the European Space Agency's Gaia mission, which maps how stars move with astonishing precision. That data shows a kind of slowdown in orbital speeds far from the galaxy's center, called a Keplerian decline. The dark matter clump model can explain both this and the rapid motion near the center simultaneously, something older models struggled with. Before we jump to conclusions though, scientists emphasize that this isn't proof that the Milky Way's central object isn't a black hole. It's just that this dark matter explanation seems to fit the observations perfectly well, and might even do a better job explaining some features than the traditional idea. Upcoming observations, especially more detailed looks at the photon rings that light makes around black holes, could help tell the two ideas apart. The idea that dark matter forms a vast, flattened structure around the local group reshapes how we picture our cosmic neighborhood. Instead of a simple, roughly spherical halo, there's something more like an enormous invisible disk stretching between galaxies. Shape matters because gravity follows the distribution of mass. A sphere tugs evenly from every direction and creates a balanced pull. A flattened sheet pulls more strongly along its plane. That difference explains why Andromeda doesn't just drift randomly, it slides along a gravitational track. But even as Andromeda approaches, the universe keeps expanding. Distant galaxies continue to rush away from us faster and faster. In fact, billions of years from now, our ancestors staring at the merged Andromeda Galaxy might not see any other galaxies at all. Expansion will push them so far away that their light won't reach us. But here's a twist. The same invisible dark matter sheet pulling Andromeda toward us also keeps our galaxy intact. The same gravity that heads us to collision also built a structure that lets stars form, planets grow, and life emerge.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.